The simplest measure of mortality is the crude death rate. The crude death rate gives the number of deaths in a given year per 1,000 mid-year population. And as a formula, crude death rate is given as deaths during the year divided by total population times 1,000. Just like the crude birth rate, the crude death rate has its weaknesses that are originating into the fact that it does not take into account differences in the age and sex composition. We all know that deaths are higher among the young and the old, unlike the middle-aged groups. We also know that males are more prone to dying than females due to risky behaviors and their biological makeup. Against this background, we therefore have the age-specific mortality rate that takes into account mortality differences in age. As a formula, age-specific mortality rate can be presented as deaths in an age group divided by the population in that age group times 1,000. To take into account mortality differences in sex, the age-specific mortality rate may be calculated separately for each sex. However, this measure has its own weakness. Its weakness is that it cannot be used to compare mortality of different populations since data is in groups or it's not in a single index. In other words, it is cumbersome. We have another measure of mortality. It is known as the cause-specific death rate. Cause-specific death rate is the number of deaths attributable to a particular cause, denoted C, divided by population at risk. And unlike the first two measures, the cause-specific death rate is usually expressed in deaths per 100,000. As a formula, cause-specific death rate is expressed as deaths due to a particular cause divided by the population that is at risk times 100,000. We also have other interesting measures of mortality. These are infant mortality rate, child mortality rate, and maternal mortality rate. These are interesting measures because they indicate the socioeconomic status of a country. They indicate how strong the health sector is as well. So let's start with the infant mortality rate. An infant is a person who is under the age of 1. Infant mortality rate is therefore the number of deaths of infants per year per 1,000 live births in that year. And as a formula, Infant mortality rate is given as deaths in infants divided by total live births times 1000. Infant mortality rate can further be divided into three. We have the perinatal mortality rate, simply measures the number of stillbirths or late fetal deaths, that is, those deaths after 28 weeks of gestation or the pregnancy period, plus deaths within first week of life in a year per 1000 births. So we are including both live and stillbirths. We also have neonatal mortality rate. This measures the number of deaths of infants under 4 weeks or under 1 month during a year per 1000 live births in that year. Finally, as part of the infant mortality rate, we have the post-neonatal mortality rate. This gives the number of infants that die from 4th through to 51st week of age. In other words, it gives the number of deaths of infants aged 1 through to 11 months during that year per 1000 live births in the same year. We also have the child mortality rate, and as we know, there are several definitions of a child. However, in this case, a child is a person between 1 and 5 years of age. And for child mortality rate, as a formula, it is given as deaths in children over total live births times 1000. We also have a measure of mortality known as the under 5 mortality rate. Under 5 mortality rate is the probability per 1000 that a newborn baby will die before reaching age 5. If subjected to age-specific mortality rates of that year. So the under 5 mortality rate combines the infant mortality rate and the child mortality rate. We also have the maternal mortality rate. The maternal mortality rate is the number of women who die as a result of complications of pregnancy or childbearing in a given year per 100,000 women of childbearing age in the population. Maternal mortality rate as a formula is given as number of maternal deaths over number of women aged 15 to 49 times 100,000. Finally, we have another measure of mortality. This is referred to as the expectation of life, Others refer to it as life expectancy. The expectation of life is the average number of years a person of a given age can be expected to live under the prevailing mortality conditions. Life expectancy is calculated using a tool known as life table. A life table is a statistical tool generated from current age and sex-specific death rates in a given population. Life table gives the values that are used to estimate the likelihood of someone in a hypothetical population dying before their next birthday. And typical life tables have the following 10 parameters. We have x to x plus n. This simply gives the age or the age group. The second column has the npx. npx is the total population at age x. Then we have the third column, D. It gives us deaths recorded at age X. The fourth column, NMX. This gives the age-specific death rate. In other words, deaths at age X as a proportion to the population age X. Then we have NQX, the proportion alive at the beginning of age X, dying before they reach the next age. It simply gives the probability of dying. Then we have LX.